All right, good morning, everybody. We're going to do a lesson on equations of lines. It'll piggyback off the lesson that you just did, right? The two big things that you need to remember, and this goes all the way back to Algebra 1. So if you're struggling with this, go back to the videos from Algebra 1, is making sure you know the slope-intercept equation, y equals mx plus b. All right, if you're in this class, that should be something you already know. And y minus y1 equals m times x minus x1, which remember, that's just a rewrite of what equation? What's that a rewrite of? That's just, nope, it's not a rewrite of slope-intercept. It's the slope formula rewritten, yeah? So, I mean, technically you don't need that formula. You could just rewrite the slope formula each time, but it's a little bit faster that way, yeah? All right, now remember, two big things. If they give you the slope and the y-intercept, and remember, the y-intercept will always be 0, comma, some number b, right? If they give you the slope and the y-intercept, you can go straight to the slope-intercept form, which is exactly what they're doing on example A, right? They give you the slope, 2, and they give you the y-intercept of -3. So could I write the equation quickly? Sure. Y equals 2x, what? Minus 3. That's it. Welcome to the world's easiest problem, yes? And then they're going to ask you to graph it. So we start where? -3, right? And then follow the slope. What's the slope telling us? You can have this in your notes. You should already know this, though. If the slope is 2, that's 2 over 1. That's up to right 1, right? So up to right 1, up to right 1, up to right 1. Make sure you make a nice straight line tonight when you're doing these. Use a straight edge if necessary. All right? And there we go. Pretty simple, yeah? Let's do it again. Example B. Same idea, right? So the equation would be y equals what? 1/4 x plus 5. Easy. Start at 5. Start of a y-intercept of 5. And then what does the slope of 1/4 mean? Up 1, right 4. Yeah? Up 1, right 4. Up 1, right 4. All right, a little bit harder. C, I'm not gonna graph C, but we can write the equation really quick. That's the slope, and what is that? That's not any random point. What point is that? Yeah, that is the y-intercept. So that's easy again, right? So it's y equals -5/3 x minus 1/3. I'm not gonna graph that, but it'd be a little bit harder to graph because you'd have to start at a y-intercept of -1/3. Remember, you're not forced to start at -1/3. You could start at any point. You know what? This is worth talking about. If I was to graph this, I would not start at -1/3. What I would do is I would plug in a number so that this comes out pretty. Yeah? What x could I put in there to make, I need to take away 1/3 at the end. If this was 10/3, oh, but it can't be 10/3, right? What could it be? Oh, it's plus 1/3? Okay, so I think 1 or if you play a little bit of math here, you can figure out numbers that make it pretty. Let me show you. That would be the equation. Let me give you one. If you triple both sides, you get 3y equals -5x plus 1, right? And it might be easier here to tell what kind of numbers to try. Yeah? You want 5x plus 3 to be a multiple of 3. So what could I do? Here you'd have to guess and check a little bit to figure out a number that works. 0 wouldn't be good. Would 1 be good? No. 2? -4. -4 takes us to 21. That's good. So if x was -4, that's a good one. So we'd have -5 times -4 plus 1, which would be 21, which would be what? So we get 3y equals 21, which is y equals 7. So we know the point -4, 7's on the graph. Does that make sense? And if I was to graph this, that would be a better point to use. Yeah? There's nothing special about -4, 7. It's just easier to graph from. So go to -4, 7, put a graph there, and then just follow the slope. What is it? Down 5? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1, 2, 3. Dot there, and there we go. Yeah? Gotta love a touch screen when we're trying to graph. All right, and then you would connect those dots and not make Mr. Gillespie rage quit, yeah? So connect the dots and make a line, yeah? All right, D is a little bit harder. Why is D a little bit harder? It doesn't give me the slope, and it doesn't give me the y-intercept. So the first thing I have to do is calculate the slope, right? So I'm going to do this pretty quick. Like I said, you should already know how to do this. So if you're struggling with this, you need to go back to your Algebra 1 videos and watch those, yeah? So negative 11 minus 5 over 1 plus 3. So what do we get? We get negative 16 over 4, which is negative 4. Slope's negative 4. All right, so then we get y minus y1 equals m times x minus x1. This is kind of what you did yesterday in your homework, right? Y minus, I'm going to use the first point, so y minus 5 equals negative 4 times x plus 3. So we get negative 4x minus 12. All we're doing here is just doing some basic algebra, plus 5, and we get y equals negative 4x minus 7, right? And there's our equation. So plug it into the point slope and just simplify it like you did in 7th grade math or 8th grade math for some people. All right, so negative 4x minus 7, so put a dot there. What's negative 4 mean? So I'm going to go up 4 instead then, right? Because I'm off the graph if I go down 4. So up 4, left 1, so that'd be here. And you guys can make a straight line. I have a hard time drawing a straight line on this screen, but there you go. Okay, any questions there? Pretty standard, yeah? All right, so passes through point 6, negative 1, and is parallel to y equals 2x plus 1. Okay, what do we know about parallel? Same slope. So we know the slope of this new line is going to be what? 2. Yeah? And we're going to use the point 6, negative 1, right? So we just plug it straight in. Y minus, actually plus 1 equals, and let me write the formula first because in your notes I think it's important to write the formula. Y minus y1 equals m times x minus x1. So we get y plus 1 equals 2 parentheses x minus 6. Distribute the 2, we get 2x minus 12. Subtract 1, we get y equals 2x minus 13. If you wanted to check it, you could check it. If you plugged in 6 for x, what should you get out for y? Negative 1. Let's try it. 2 times 6 is 12. 12 minus 13. So that's telling me that that point is on the graph, and it's parallel. All right? All right, what did we learn yesterday in your assignment? If we want to find the slope that's perpendicular to, the slope is 1/3, so what would the perpendicular slope be? Negative 3. Remember, flip and negatize the slope. If you're struggling with that, go back to your notes from yesterday, or go back to Algebra 1 and look at the perpendicular parallel lesson. All right, so let's plug it in. Y minus y1 equals m times x minus x1. Y minus 6 equals negative 3 times x plus 2. Distribute the negative 3, so we get negative 3x minus 6. All right, plus 6 plus 6. We get y equals negative 3x. Let's go play back in time. What's the y-intercept of this graph? Origin. When a linear equation goes through origin, it's a special graph. That's a direct variation. Yeah, remember that? So it's not part of your homework tonight, but that is a direct variation. If you're asking yourself, what the heck is a direct variation? Go back in time and give your Algebra 1 teacher a sad face because they should have taught it to you. So, all right. Why is C a little bit harder? We don't know the slope yet. Okay. There is a way to get the slope. I mean, the slope will, there is a way to get it, but I'm not going to get into that here. All right. So we're going to rewrite this, right? So 2x plus 3y equals 6. We're rewriting this in slope intercepts. We're rewriting this into y equals mx plus b. So bring the negative 2x over, right? So we get 3y equals negative 2x plus 6, and then what? Divide everything by 3. We get y equals negative 2/3 x plus 2. I did all that, right? I did all that to get the slope, right? So that's the slope. The slope is negative 2/3. Incidentally, I teach this to the math team, but when it's in standard form, right? When it's in standard form, that's a and this is b, right? A is 2 and b is 3. I teach them this. Negative a over b is going to be the slope. So you could do it that way. You take 2, negatize it. Negative 2 over 3 is negative 2/3. That is the slope. Okay? All right. So then we just plug that into the point slope formula, right? Y minus y1 equals m times x minus x1. Why are we not flipping and negatizing the slope this time? It's parallel. Good. So we get y minus 10 equals negative 2/3 of x minus 4. Distribute the negative 2/3. It's going to get ugly now. So negative 2/3 x plus what, everybody? 8/3. Now watch what I'm going to do here. When I add the 10 to both sides, I'm going to call 10 30/3. Yeah? So I'm going to add 10 to this side, but when I add it to this side, I'm going to call it 30/3. What is 30/3? 10. It's another way of writing 10, right? So we get y equals negative 2/3 x, 38/3. And since we're not graphing, who cares? We can just leave it. All right? I mean, if they did ask you to graph it, I don't know, are we asking us to graph it here? All right, so, I mean, we can go back and do a couple of these. We're gonna have a hard time graphing. Let's just graph this one, yeah? Let's just graph C. If I was to graph the first equation, what method did we learn last year that's easy to graph that? Cover-up method, right? If you don't know the cover-up method, you learn it in, I'm gonna do it here. If you want to find the x-intercept, you cover up y, right? So you get 2x equals 6, so that's 3, right? And then if to find the y-intercept, we cover up the x. We get 3y equals 6, so y is 2. So there's my first graph, right? All right. And then graph my other graph. Now here's the deal. I would not use 38/3 to graph it. What could I use? You could, but even better. Is there anything special about the y-intercept? No. It just typically is easy to graph from, but it's not in this case. What point could I use? How about the point they gave me, 410? Yeah? So graph 410. So graph 410, that's up here. And then follow the slope down, which is what? Down 2, right 3. Down 2, right 3, I believe, right? Nope. Not left 3. Down 2, left. So there we go. What do we notice about this line? And that's the whole point of this, right? To be parallel. All right. All right, this last one, I actually find it's better if you sketch it first. Okay, y equals negative 5. What's that going to look like? Horizontal line at negative 5, right? So I don't need anything to graph that. So that's like this, right? Pretend that's a straight line. I really have a hard time graphing straight lines on these screen. Got it? And then what? If I graph negative 4, negative 2, that's here, right? And if it's perpendicular, what does that mean? Up and down. So a perfectly horizontal line is perpendicular to a perfectly vertical line. Now, what's the equation of every vertical line in the entire universe? X equals a number, right? X equals a number will always be vertical, right? All right, so x equal number is vertical. So x equals what in this case? Negative 4, because that's what the x coordinate is. So that's the equation of the line that's perpendicular to y equals negative 5. All right, so that's all there really is to it. It's a good piggyback of what we did the day before, yeah? And I think you just covered most of the first 6, most of the second 6 weeks of Algebra 1 right there in those two lessons. That's what you did for the first 6 weeks of Algebra 1. So, all right.